Okay, welcome to assignment 3, the last task, which is task 6. The task 6 asks to find the fracture strength. So this is the point where the material fractures. So let's read the description. Fracture strength. It's the stress. So although the graph is showing us on forces, it's showing us where the material yielded, where the material fractured. But the definition of the yield stress is the value of the stress, not the value of the force. It says that all here in the instructions, but somebody asked me, well, the graph shows that yield is different, but this is not the value of the yield. This is where the material yielded. And same for fracture strength. We're looking for the stress. What is the value of the stress at the point just before the material breaks? So looking at this graph, how can we extract this point here automatically, easily, with code, elegantly? What can we do? What makes this distinct from everything else? We need to think about that a little bit, don't we? So the distinct feature is that the value suddenly jumps down. It was up here and then it jumped. How can we find the biggest jump? The biggest difference between consecutive values. I'm going to keep saying the word difference now. And that's exactly it. We need to use difference. So first thing we do is we're going to create a variable called stress difference. Or just stress diff, I think is enough. Diff is the diff. Remember, we've used diff before. It gives you the value, the next value of the vector minus the value before it, then it puts that somewhere, then it gets the value after that and takes the minus the value before it. We've done this before, so I won't go into too much detail. This thing is the jump. That's what we're looking for the jump, the biggest jump. So let's plot it. Let's just plot stress diff. We'll plot it against strain just so that it appears in the same place. So remember, plot, 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 plot. And press run pretest as much as you want to. I should press that before. Wow! Vectors must be the same length. Same mistake made from assignment 2, right? Remember, diff removes an element. So we have to remove an element as well. So we remove the first. Whenever you apply the diff function, what it returns has got one element less than the array you put in here. All right. Ha! Do you think we can identify where material fractured from here? Looks like something happened here. That's the fracture, of course. There was a huge jump. So all we've got to do is find the position where there was a huge jump. So let's do that. Notice that it's like close to 0 and then a huge negative number. So all we want to do is we want to find what is the minimum value. The minimum value, where is there the minimum value in this vector? Once we have where that minimum value was, we'll be able to find the stress. So let's go to MATLAB documentation here. So I want to find something about the minimum. So let's look up minimum. So here are some ways to use it, but what does it mean? M equals min of A returns the minimum value. Sounds about right. We want the minimum value. But we don't just want what was the minimum value, we want where the minimum value was in the array. So this is where it would take you a little bit longer to find out where this is here, but the tip, it is here. M, I also returns the index that corresponds to that value. So it means it tells you where it happened. So let's copy that. Let's copy that. There's some examples on use below, right? I think examples are easier to learn from. So is there somewhere we can scroll down to find an example? Come on, example. Here it is. Here's some array A. 1, 9, minus 2, minus 5, 4. And you've written min of A. And by writing this on the left, we're asking MATLAB to return what is the minimum value along what appears to be the columns, and the indices where they occurred. The first, So the first out of these two was the smallest. The second out of these two, says here second is the smallest, and the second again was the smallest out of these two. Okay, let's copy that. Let's go back to the assignment. So what we want is we want the minimum value, and here we can put m, and here we can put whatever I, the index. So again, as I've always said, let's check, how can we check it works? Let's leave it, just print this out actually. And just to check that how we use I is where m occurred. So just put I in here to see if we get the same value. Let's run this. Okay, we don't know what that means. It says it's minus 1.6 10 to the 6. Applying the index also gives the same value. Let's see if that's about right. Minus 1.7 times 10 to the 6. Scale is 10 to the 5. Here is 10 to the 6. 16 times 10 to the 5 minus 16 times 10 to the 5 is about 1.6 times 10 to the 6. So it's right. We could check that in more detail with a plot, and I would recommend doing that actually. But that is where the stress occurred. But that's where in the vector the stress diff it occurred. But what about in the vector stress? We don't. That's what the question asked for. It asked for what was the stress. You need to give an index here, a number like 6 or 60. Where was the stress just before fracture? So a very good guess is to use I. Remember, this vector has one less length than this one, so I might be wrong by plus or minus 1. But as long as you're getting the values of the stress just before fracturing, even if it's close to here, it doesn't need to be exactly this value, but one of these, that will be correct. So how can we assess that? Again, a plot is the answer. It's always a plot. The plot is always the answer. So let's plot the strain against the stress. Let's see if we've got hold off already. Yeah. Let's do hold on. Hold on, because we want to do two plots on top of each other. And let's add a straight line. I'm going to do a straight line a different way this time. I'm going to take the whole vector of strain and multiply it by 0. So the value is just 0. There's a bunch of, this is now going to be a big array full of zeros, right? And then I'm going to add to every single element of that array the value of fracture. So this will be a constant, a vector where all the values are just the value fracture. Just thought I'd try to do it a different way than the last time. So this will also be a horizontal line, hopefully. Ah, look at that. Oh my God, the perfection. The line is passing exactly through the point where the material fractured. So that is the value of the stress when it just before fractured. So that is what we call the fracture strength. So this is correct. Thank you. Hope you enjoyed this assignment. Bye-bye.